Okay, let's go over to the stream and do an audio check. Okay, sounds good. Camera looks okay. So I guess we will get started. Welcome to the stream of the Discourager of Hesitancy. We are making a game with no game engine, minimal dependencies, and just trying to build everything from the ground up as partly a learning exercise and partly as part of the battle against over abstraction, obfuscation, obtuseness in code, etc. So while we get started, I'm gonna fire up my beverage of choice while we get going. We've done a lot of animation stuff last week, which was good because we kind of discovered the requirements for our animation system. And I think we just about have all the things we need for now. So one last day to get a couple more things animated, and then we'll move on to something else for my checklist. My checklist is still quite large, so work to be done. But before we get into that, we're going to go clean up the journal. There was two things I was going to do on Friday that I did not get around to, so we'll start with those today. And here we go. Okay. So let's go over to the journal. We've been doing this for a couple of weeks. So one thing I want to do is actually mark out weeks, right? Streaming week number 2 or O2 for now, I guess. And then we'll make each of these 5 dates a sub element of that. And now those are all in week 2. Streaming week 1, because that was the first week. 1, 2, 3, 4, and 5. Okay, everything else I did pre-stream. So all of these other things are going to be made children of that. Yes, this should be fine. Oh, what? Let's see. Ah, and then here I am doing the same thing. So star 2023 with star 2023. And this should go back to when I was working on it very sporadically in my free time with the day job. So this kind of gives me a way to break up what I've got here. Week 1. Now with week 2 done, I need to start up streaming week number 3. We will talk about the tasks shortly. One thing I did not do at the end of week 2 that I want to start doing is lines of code. We're going to break this into 2 parts. Well, yeah. So we're going to take all code, generated data code, I'm going to call it, and then net code. We could build a table in org mode with that, but let's just hold off on that for a second. I'm gonna pause for a second. Okay, we're back to it. Because I want to keep track of these strings. So let's go to the shell, and we're going to do word count line cd into source directory, word count lines, star.hpp, star.cpp. That'll give us everything, which will take a while. Okay. So that's our total lines of code right there. Now, the generated data code, we're basically looking for anything with the word warehouse in it. Meaning, I didn't manually write this code. I wrote code to generate this code. So I'm not going to count it towards our code growth, but I am going to also keep track of it separately for because that way I'll know how much my assets are costing me in memory. We will have at the end of the project let's see, shader warehouse and sound warehouse are both the same size. Cool. No. And the image warehouse. Font warehouse. Yeah, most of my headers are about the same size. That makes sense. Okay, so we should have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I think it's all there. So what we can do is actually just do this and make this into Lisp because we're in Emacs, so we can execute arbitrary Lisp if we want to. Well, let's see here. There's a way to run it and insert it, but 206.994, 206.994. What was it? Let's see here. I'm going to Google that real quick. Emacs, execute S expression and insert result. We're going to check that out. Eval buffer, evaluating by S expression. Control X, Control E, which I did. Control X, Control E would not evaluate special forms, blah, blah, blah. Metacolon. U, okay. Maybe we try that. Control U, Control X, Control T. There it is. Okay. And now we have that, which means this thing can be 218 996 minus 206,994. UXE, and there's the totals. So we're at about 12,000 lines of code now, and 207,000 lines of generated data that's being embedded. So now that's recorded. And next week we can take a look at the numbers again. Okay, good. Tasks. Clean up journal by week. And add lines of code to week 2. All right, first thing is done. Always got to have your documentation right so you don't lose track of what you're doing. All right. So I said we were going to animate 2 things today. If we have time, we will start on another task. We will see how far we get. Gameplay, add animations, letter color change. Oh, yeah. Okay, bookcase letters animated. And we'll try to get to the remove words at the end of the level and enter the level kinds of things. Colors animated as well, like the alphabet. That is a gameplay task. Yeah, that's a documentation task. Okay. So fall, zoom off, alpha fade, yep. All sorts of things. Okay. The bookcase letters have been the one I've been most hesitant to do because until Friday I didn't have the features I needed to deal with them. Part of the problem is that the alphabet I can deal with one letter at a time because each letter is its own text object. But the guess words are, and the accompanying matched number index, matched number count, is a single text object. So animating an individual letter is slightly more complicated. Now the color itself is easy enough, but if we want to move and animate the letters on the bookshelf, the same as we do the letters on the chalkboard, will take a little more work. We have to actually touch the vertex buffer that we're passing to OpenGL to render. So we may get into that. I do have 1 or 2 other things I'd like to play with. So maybe we go with that task next if we still have time. But here we go. One. Collapse that. Okay, this one is done. All right, bookcase letter color animations. This one is the tricky one, and then we can take an easy win, I think, with this one. Several variations on that one. Okay. All right. So it was in set letter state char. This is the one. Now, if the state has changed, so in other words, if you click on a letter and nothing changes, this just short circuits that. Oop, no. Here. We may want to break out these into functions as this function is getting a little bit long, and it's only going to get longer with this chunk being replaced with actual animations. What does this else go to? Ah. Okay, so this is the not animated chunk. Let's go ahead and break this up. Game scene. So set letter state is going to get two versions. Void set alpha letter state alphabet. Void set letter state guesses. I'm not too worried about function calling overhead, and this is not an every frame kind of thing. It's only on certain user inputs. So we're going to interesting. This for loop should be in here. Set letter state alphabet for all the properties we got. Collapse everything back to where it should be. Now we don't need this comment. The only thing left to do is to pass in all the things we need. The last state, animation method, delay method. Boom. I'm going to change the name a little bit. Alphabet animation. Animation. A little bit more descriptive. Which gets this. Okay, looking pretty good. Let's just make sure that refactor didn't break anything, doesn't cost anything to test. It does cost us something to test. Okay, I know what that means. know we aren't using it yet, but we will. And I know these aren't being used, but they will, so that's fine. Only I put the letter B back in. When I accidentally delete it, that would make life better. Or at least more compilable. Now, so those not animating, all these are animating, is exactly the problem. So those animated, these did not. Thought we had out. Okay. So something. What happened to D? Why did D not go away? And it does a weird animation thing. Oh crap. New bug. Those went in. But these did not work. Oh, double clicking the H worked. Double clicking the M worked. Right click is just not doing what I want right now. Huh. Ugh. Alright, going up to the bugs. Not being rejecting all letters correctly. Okay. Shoot. Do I want to chase that bug right now, or do I want to just get the animation stuff going? What I don't have is a good understanding why it sometimes works and sometimes doesn't. Like, what's different about the letter C than in proud, right? What if we do this one first and then this one? Oh, interesting. Right click seems to be the biggest problem. Seems to be most related to the right click. Double right click, not rejecting letters correctly. First one works. after that misses letters. We'll keep an eye on that one. We might tackle it today if it annoys me enough. Okay. Yeah. Okay. So we sort of want to follow this general pattern here. We're going to choose our delays. We have the different animation cases. But this information is all going to be different because we're not working with the letters text objects anymore. We'll be working with the guesses. So let's just paste that in there. And we're mostly going to comment out this stuff. Just for now. We might as well make this available. That's all the same stuff. These are all going to be unique weight. So that's fine. The tag will have to change. So let's figure out the tag. So we use the tag letter color change plus the letter offset. So that's from, I think, 2 to 28 or something, 27. So we just start after that. Then we need to add the word. Times 26. Sorry, 26 possible letters per word. That a thing. Two plus 26. Let's just go with 30. Plus, there are as many as 20 guesses. Times 26 letters per guess. So 400, 520. Yep. So if we're looking at the 20th guess and we find the letter Z, that's the biggest offset we need to supply. 520. So the next thing up probably be 550. Oh, plus, oh, okay. The other thing that gets more complicated. Word index times 26. Plus letter index. Pretty sure that's it. We just don't have the word index calculated yet. Which is this line here. For each word, we need to ask some questions. Does the word contain letter C? That's question number 1. So here, from before, we were just saying, go set the letter color, and I'll let the text object itself scan through looking for that letter. But now I'm thinking we need to make some changes. We need to ask letter index our character. We'll make that a const because we are not modifying anything. Set letter color. I want set letter index color. And this is then a shorthand for these two things. I can reuse this code quite a bit now. Set letter color. And let's just copy this and then go back up. Oh. Set quad color. There we go. Quad index of letter. That makes more sense. Quad index of letter. Okay, if they are equal, then we quad equals let's see here. Quad equals 0. But quad is only incremented if it's a visible character in the ASCII range. There we go. Result is -1. We will return a negative number. Result equals quad. And break. Return result. Int quad equals quad index of letter C. Let's just keep this code around in case I want it back later. But it should simplify down to that. If the quad colors at quad not equal to the color, then we queue up the color change. And the fact that there's no Boolean or equals in C++ is a little bit sad. Okay, so that should have changed nothing in theory. So let's test that out before we get too far. Oh, we're gonna go back to this anyways for now while we test that change. Oh, set quad color is already existing. Which probably means it's overloaded. Vertex buffer color. Set quad color. This one, I believe, is the actual vertex buffer. Set quad vertex buffer color. So here's the thing. We have a color per buffer per character quad, but that color is not propagated into the vertex buffer until we're ready. So when we go to render the text, we ask, is the color dirty? Like if the color dirty flag has been set, then we update the vertex buffer, because what we don't want to do all the time is this vertex buffer update. Update means we have to tell the GPU that our stuff has changed, then send the data, and that takes time. So unless something has changed and that dirty flag has been set, we don't actually update the vertex buffer until we have to in a render. So when I do this set quad vertex buffer color, it's actually inside the vertex buffer. But this set quad color is not going to do that. It's going to set the color we want added to the vertex buffer. Which is in set letter color right here. So this is next thing. Set quad color, quad and color. It's set color. Insert index greater than 0. Insert index less than m_quad count. What do I call quad count? Now I can't remember. Batch quad count. Of course I did. If those two things are true, then we check to see if the color of that letter is the same as the color we're trying to set it to. If it's not, we set it, and then we set that flag saying we want this color to be updated in the vertex buffer by setting the color dirty flag. Okay. That should fix a few things. Quad was not declared. I don't believe it. Oh, probably index. Okay. That should run without a problem. So, it's crashing. Oh no! Index greater than 0. Did I? Greater than or equal to 0. That is what I meant. Obviously. Okay. And that still crashes. Index greater than or equal to 0. Oh. I know why. We can't assert that. If index is less than 0, it's greater than or equal to 0. Because, no, I do want that assert back in here. We're going to check it somewhere else. Right here, set quad color. If quad greater than or equal to 0, then we do it. I'll run this. Try it again. Okay, those seem to be working. Interesting. Okay. Okay. So this is still working. Didn't break anything. Surrender, quit. All right. Which means this can all go away. This code is now reusable. A lot of people tend to over-engineer. I think they want to create reusable code if they think they might need something to be reusable later. But I find it's best to only go reusable when you've made the same code twice or about to make the same code twice, or maybe a third time even. Sometimes 2 is like, we'll flag it as maybe pulling it out into a function. But in this case, I do want it separate because there are things we want to do with the animation that needs to be like, hey, we need to work with the quads of this text. So getting a index of the quad letter and setting this are going to be very useful inside of our animations. So now it's time to pull these out and make them separate. This does introduce a little bit of overhead from what we had before, but the cost is not that great, and the reuse is going to be good. So. Okay. Back to the game scene. Dum-dum-dum. Set letter state. This one. So no, we haven't broken anything yet in that section. So we get our new action sequence. It's going to be a unique. It's going to wait for the other sequences with the same tag number to finish. And we'll make an animation whose duration is that. Easing method is that. And then the set the range is the only tricky part here, because this lambda function has to change. So let's do this. Int quad index equals underscore guesses text. Let's go and get the guess text out of here. Multicolor text winner text equals the address of this mess. The quad index will be text point to index quad index of letter C. Now I can work with quad index. We could even shrink this down quite a bit. Instead of taking up 26 possible alphabet letters per word, we only use the quad index, which means at most it's going to be 5. I kind of like that. Twenty guesses times 5 letters per is 100. So the next tag could be at 130 without any problem. Instead of 26 and letter index. Something like 26 plus letter index. We're going to go with 5 plus quad index. There we go. Okay. Now, text. Oh, let's go ahead and make it actual text. In this case, the animation is done. We have the last color, we have the selected color. The text is going to set, instead of set color, it's going to be, we need to capture the quad index. Set quad color to C. The interpolated color value between last color and selected color. I think that's it. Let's try it. Oh, no. Index. Why are we calling it index? Yes, index. Nope. Okay. Word index to yes index. Do I have the word index anywhere else that matters? Yes index, quad, guess, quad. Guess, quad. Okay. We aren't abusing the word index too much. Oh, okay. Quad index. All right, we're getting close. Assert sequence not equal to. Okay, so we have to declare the action sequence. Wait a second. Outside. Pull this outside. Yeah, we don't need anything else. Very close. R. Like something rectangle related. That's fair. Actually, no, this has to go inside the for loop because it's on a per word letter basis thing. Where's it getting R from? R. Not using R. And R depends on which quad in particular we're looking at. So I don't want to do this. Although we can do something. Let's see. We can copy this idea. Actually, let me just check this real quick. Is x0 being used anywhere except the very bottom? Here, it's not. And x1. We can literally move this whole chunk down to where it matters. The only thing it matters for is actually the wave option. So simplify the code a bit. That's really how it wants to animate. The break there. This can go inside there. Similar achievement here. I really, really hate computers trying to guess what I want to do and doing it badly. There we go. Wait, so back down here, instead of X, though, I want to do it by Y, just because. Oh, hold on a second. We already have the text object here. We don't have to do that again. Oh, wait, text 0. Nope, that has to be that way. Okay. So this one we want guesses text 0 and 20. Ooh, let's see here. Underscore guesses, max guess. What's it called? Game scene. X. Guess count. Guess index. Guess count. I think is the one I want. That one. That one. quarter second scaled by y. Okay, that won't matter too much until we get to it, but this first animation should be good. This one should set the color of the letter to change on the bookcase with a fade animation. R not declared. Okay, so we do need the R outside here. Which means we'll need that similar treatment to this one, because it will have a similar issue. So text sequence rectangle. Except we can put all this inside of an if condition. If quad index is greater than or equal to 0. Okay, we should be getting somewhere. Let's see. Second. It's a little drama queen. Gets bumped. No injury. Gotta make a big deal of it. Problem when he's smaller than his brothers, he kind of feels like he has to make a big fuss to keep from getting run over. Let's see. Text. Okay, I guess we do it here. Try it again. Used variable letter index. That is fair, actually. We don't need it. Not in this one. This one we are concerned about quads, not letters. Okay, so if we, good, that faded to green, fade. Okay, so that seems to work. Those animations all work. Good, good. That's the first one. So as these ones fade, so do the ones on the bookshelf. Good. Those are all synced up. Very nice. Okay, back to it. The second one is also not bad. Color. Last color. So we go from the last color to alpha, right? We fade it all the way out. The only difference is this. This is basically the same exact thing as above. So we do that. And this one fades from alpha completely out to the color itself. Similar song and dance. We may move these onto separate lines just to make things line up a little nicer. So from last color to the new color. From the last new color, from the hidden color to that color. And then we apply that change. That should be it. So now the fade in out should work. And in the case of this one, the delay should be this wave from the bottom to the top. In theory. Let's see how that looks. So now the blackboard will fade left to right, and the bookshelf will fade bottom to top. I'm sure I'll want to change that all later, but we will just get it working. Oh, okay, well, you know, that's fair. TOADS. Let's just select some other things. No, okay, doesn't matter. J doesn't matter. What do we got here? R. No, not a G. M. Maybe a H. Okay, so when we hit clear, it should fade bottom to top. And that's not at all what happened. Well, shoot. Why not? We should come in with animation mode fade in out. Got the new action sequence. Am I missing something? This should behave very similar. Set quad color. I'm not getting any printouts that says I have some hanging animation sequence, action sequence somewhere. This one is working, so I know it's being called. It's just like this one. Fade in out. Then it should set a weight based on its Y position. Sequence was declared right here at the top. It's not null. We can't get here. Ah, interesting. So what is happening? You can set a breakpoint and try to follow. Oh, game scene line 1020. Game scene.cpp line 1020 run. We want lots of words to look at, so prime guns, ultra demon chips, laced rhino, stump, crowd lines, match. Okay, so we can do things like PROUD STMENAL so CH. Yeah, everything else is out. So when we hit clear, we should get our breakpoint. We're not getting to our breakpoint. Oh no. Did it bounce all of those? Bounce. Bounce. Oh no. So which one was the sweep? What was the sweep? What triggered that sweep? Now I'm having some memories. Where does this go? Show deduction space. That's the one. Okay. All right. So if we go PROUD STMLINE A, then everything else is out. So this is the actual deduction. If we go to deduction space 2, so the journal 2. Oh dear. Is that our breakpoint? That is our breakpoint. We'll remove the breakpoint. Nope. Well, whatever. Clear the breakpoints. I don't remember. PDB clear breakpoints. Delete with no arguments. Okay. And I think it's just C, right? Continuing. Oh no. Okay. Boom. Boom. Okay, so that works out pretty good. Very nice. We may fiddle with this a little bit later on where we go X all the way across from the bookshelf to the whiteboard in a nice little wave. We also might change it away from quint and leave it as quad. Okay, so that's working. That one is working, it's just not the animation I thought it was. I want to play with that. Let's go to quint. Go to, no, this one's fine. Where's the other quint? Wait, uh-oh. Set letter state. That second animation is quad in out. Okay. I might make this faster. 1875? 875. 1875. One eight seven five. 1875. We may also come through and set all these little durations for animations to be like constant static numbers. That way we can just change the behaviors all at the top, make something snappier and something drag on. Toads, ultra even chips, placed rhinos, match. Okay, so LINES chips, CHP, demon, DMO. A is in, T is out, U is in, R is in, BD, vlogs, jacks. So FG are out, B and Y are out. J or K? Ooh, no W or X. J or K. So no J, but there is a K. And at this point, it doesn't matter because we're going to workspace to journal 2 to notebook 2, notebook 2. Swoop, swoop. I think I like it that little bit faster. That was a tiny bit odd with just these characters staying unchanged, but I'm not too saddened by that. Hold on, checking the phone. I don't do robocallers. If you aren't polite enough to call me, then I'm not gonna answer. Okay, so that works out pretty good. Workspace 2, workspace 1. Yeah, not bad. Sweet. Okay, so that one's done. We surrender. Oh, it's Quark. Who knew? But, okay. Now the last one. This is the one that's going to be the hardest. Okay. So we're just going to uncomment it for now. The hard part are these things. And the hard part is we don't want to move the whole word. We don't want to move the whole word relative to the word. We want to move a letter relative to the word. So we do need this rectangle height. So this is the height of the full text thing. We're going to make it bounce the same height as anything else. So we do need that value. But what we need are the 4 vertices of the quad itself. And we're going to modify all 4. So rule number 1, we have to break I need a function for it. Void get quad vertices int index. Now, but we have our 4 points. So double x naught, y naught. 1, 2, 3. 1, 2, 3. And we're going to make these all pointers. And boom. Set the quad color. Let's change the order just a tiny bit. Let's put the two getters, accessors next to each other. Okay. Let's set the actual coordinates. Assert quad greater than or equal to 0. Assert quad less than underscore batch quad count. If that is the case, then the contents of x is 0 equals this mess. Contents of y 0 equals this mess. It looks like we have a pattern here, sort of. Sort of. Okay, well, let's just do it that way. x1, y1, x2, y2, x3, y3. There we go. That's it. That's all we have to do there. We are going to allocate those one time up here in the stack. So double x naught, y naught, x1, y1, x2, y2, x3, y3. Now we can use that in this loop without ever having to get new values on the stack. Going to get quad vertices. Given my quad index and the address of all of these. Some alternatives we could put in the multi. No, I don't really feel like doing any of those other ones. In the multicolor text, we could have like move quad to or move character to, or we could do things like that, but I don't actually want to do that. Do I not want to do that? Yeah, I don't think I do. Search for comma space, put in an ampersand, mark it. Address, address, address. Okay. Now, setting the range from basically 0 to the height of the text box. We send along the text, and we send along x0, y0, x1, y1, x2, y2, x3, y3, and double delta y. Text, move the other thing we need from here. Set quad, which needs the quad index. Not yet seen. I want the multi-color text. Set quad vertices index. This is not a const, and these don't have to be pointers. There we go. We are mostly going to copy this, and with a small change, just like that, it's the other operation. Okay. Now, set quad vertices. The quad index. This is getting very busy, so let's do this. Quad index 2 x0 plus dy. Nope, it's x0, y0 plus dy. X1, y1 plus dy. X2, y2 plus dy. And x3, y3 plus dy. That might just be it for that one. The bounce out. So we can set the range similarly, 0 to minus height. 0 to height. Double change in y. Quad index. And all of this mess. This is long enough that we might as well break it out into lines. Set quad vertices, quad index. Basically this whole mess again, except for subtracting the delta y. Oops. Plus 2 minus 1, 2, 3, 4. This is the lift. This is the drop. What was this? What were we doing here? Other sequence. No, let's see here. One. Set immediate. Huh. I don't think we actually need that. One, two. We only need 3. Is that true? I think it is. Okay, so we don't need it here. Two. Remove. Pretty sure this does nothing. Possibly left in from testing, but since it's an immediate, it's immediately run over by the first animation, so we never see it. Possible. 4, 3, 1, and no point in allocating more actions than we need. Okay, last piece. Instead of text set color, it'll be set quad color. Quad index. Okay, it might be something like that. If this works first try out of the bag, I will be very impressed with myself. It happens sometimes, but not nearly often enough to let me build up much of an ego. Filed, that's good. Okay, now let's get a whole bunch of words. Oh, we didn't do chips. We're still. Okay, well, bonk. Oh, it didn't fire. Oh no, it might have, because none of the letters here would show up in any of these words. So that's fine. Beady, flogs, jacks, waxed. Okay, so if we clear. Oh, well, you know, that's not quite right, but it is interesting. All right, we are stretching something out. And that is almost progress right there. Oh, the other thing I wanted to check was if removing this made any major difference to the alphabet. So we should check that. while we're here, while we're in a compiled running state. Play. Those all look fine. Those all look fine. So yeah, that step was not needed. Boom. And boom. Okay, which leaves me with, what have I done? We get the quad vertices. X0, Y0, X1, Y1, X2, 2, X3, Y3. 0, 0, 1, 1, 2, 2, 3. So I believe I'm getting all of those indices correctly. Then we say we go from 0 to height of the text box. Set quad vertices 0, Y offset, X, Y offset. X2, Y offset, X3, Y offset. Zero, Y, 1, 2, 3, minus dy. Okay, so why? Why is it stretching those out? It's moving the bottom points more than the upper points. So close. Almost one-shot it. Almost. Go back and look at the code while it's running here. All right, let's get a bunch more toads, culture, demon, chips, beast, rhinos, stump, crowd, lines, match, BD, flogs, jacks, waxed. Okay. Oh. Okay. That is very inconsistent. All the problems happen in the first 2 letters. The last 3 letters in the word change without problems. Although these ones just pop. Interesting. Only the first 2 characters get messed up. So if my quad index is 0 or 1, everything else works fine. Text. Given the guess index. And the last 3 letters never animate, but they do pop to done. Quad index of letter. If the letter is found, Go ahead and get the little rectangle out of there. Yes, thanks. Only used for setting the tag. Quad index. Is used in the tags and in setting the quad color, which worked fine, and setting the quad color, which worked fine. The tag, which should be okay. Set quad vertices at the quad index. 1, 2. And here. So the quad index is never modified. This is firing off because the last 3 letters, although they aren't moving, are popping. So somehow the last 3 letters are affecting the first 2 letters doubly. Let's go look at set quad vertices. Oh. Okay, so you have different dirty flags here. If the text is dirty, it means we've changed the actual text. So that will require a full relayout, new quads, everything will have to be updated. Position dirty might be what I want. If I change the font, then I have to relay everything out. If I change the font size, I have to relay everything out. If I force things to mono width, which I am, I have to relay things out. If I set the rectangle, set alignment requires me to dirty everything. So I think I just have to do this when I set the quad vertices. That might help some. I set that flag so it's sure to update the vertex buffer correctly. Vlogs, jacks, wax. Wow. Okay, so if we just hit the X button, so those just pop. They didn't move. Huh. They aren't moving. Render. If anything has changed, we update. Okay, the quad batch count doesn't change. because we tell the same number of quads. If the text is dirty or the position is dirty, really relaying out all the glyphs. Oof, that's actually a bigger load than I wanted. And then I see what's happening. So we say set things, we overwrite this area, right? This area of memory we're setting to whatever we send in. But then it comes in here and says, oh, the text is dirty or the positions are dirty. We relay it all out. So everything I wrote in is being overwritten here when we try to render. So we need another flag, not position dirty, but just force update maybe. Cool, m_force update. Vertex buffer update. That's right after color, yes. So instead of this equals work. Okay, so down in update text, none of these will be true. Where do we actually call the update? If. So it should skip over everything here. Okay. So in other words, this function or m_force monolith or force, what was it called? Force vert buffer update. Now it won't relay out everything. Oh, yeah. Yeah, that should not relay out everything. In theory. All right, let's fill it up. Toads, ultra, based rhino, chips, proud lines, match, beady frogs, jacks, back. Okay. Okay, all right. Bonk. Yeah, the first two letters are getting definitely messed up. Oop. Huh. Okay. Another possibility, we're getting the, oh, you're not getting the wrong quad index. Oh, hold on. Huh. Why is it only animating things at index 0 or 1? Contents of X and Y, contents of X and Y, contents of X and Y. Those are all from different elements of the vertex bucket. Okay. Let's put in here a log statement. I'll note bouncing word character okay, so it is under guess index, quad index, text point to, I think it's just called text. There it is, text. Bouncing. Okay. Chips, dump, BD, flogs, jacks, waxed. Okay. Boom. Okay, words. Let's see here. 1, 3, 5, 7, 9, 11, 12, 13, 14, 15. So these are all consistent, although that's fine. 0, 3. So in flogs, G. Jacks, the K. Waxed, the second, the X. BD, the D. Or the Y, the Y. Huh. The word, quad index. All this is looking reasonable. Okay, let's take a you know what? Let's put the tag code in. At this thing. Sequence point to tag. Oats, ultra demon chips, laced rhino stump, crown, lines, match. 80 flogs, jacks, wax. Okay. Every one of these should be unique. 90, 95, 98, 100, 103, 105, 107, 94. So it's not a problem of blasting the wrong animation. +30 plus 60 plus 0, 30 plus 65 plus 0, 30 plus 65 plus 3, 30 plus 14 times 5 is 70, 100 plus 0, 100 plus 3, 105 plus 0, 105 plus 7 plus 2, 12, 60, 30, 94. So these tags are correct. These are unique in the animations. Gosh, that's weird. To be fair, we really haven't tested any of this change, so yeah, this is so close to just being done. Then we can get a snack. All right, well, clearly all the information at this point is correct. Let's see here. Let's look at waxed, I guess. Why not? So if do I have string compare stuff in here? Nope. C string. Your count text text with wax. Oh, probably a stir end comp. 5, which is that before or after? String stir end comp. Let's see. Buffer number. Five. Compare 5 bytes. Equals 0. Okay. So one thing we want to know is angle waxed equals what? Text 0.2 bounding rectangle. I think 3 integers. So that is r dot x, r dot y, r dot width, r dot height. Okay. Letter quad. So that would need the quad index. Point 0. Okay, come on. 0. X0, Y0. One, 1, 2, 3. 1, 2, 3. 3, 2, 1. See if this even makes sense. Oh, well, here's one possibility. What if these are inverted? 1, 2, 3, 4. So instead of moving, I'm thinking screen space, but this is vertex buffer space. So to move down, you subtract. To move up, you subtract. To move down, you add. That might help. We're still going to log this. But now maybe we have less confusion. Note, of course, text. Point to text. There we go. Alright, play. A bunch of words in here required. Lunch, codes, ultra, bean, chips, placed, rhino, stump, crowd, lines, match, BD, vlogs, jack. Wow. Okay. Now when we hit X, oh, interesting. It actually flipped the A upside down. And the F went up. Interesting. Right, well, letter 0 quad. And letter 2 quad. This one actually looks more suspicious. This one looks good. What happened to letter 2? These don't look right at all. This would put it at the same X position as letter 0 of waxed. Yeah, 3 and 23, 23 and 3. I would expect pairs of X's, just like here, 3, 3, and 23. But I'm not seeing that here. There's 31 and a 47 for some reason. the y values are coming in pairs like I would expect, and they are within reason. So what happened to the x coordinates of the second character? Well, the third character. Huh. Okay, well, what if we clear it? Woof. Huh. Is get quad vertices not working properly? Those x values are suspicious. x0, x1, x2, x3. Those are in order. Is it getting... Get quad vertices. I'm so confused. It should be a quad. Like it should be a rectangular quad. This is not right at all. These x values. These y values look fine. Oh. Strange things are happening here. Get quad vertices. X, Y, X, Y, X, Y, X, Y. Oh. Okay, well. Okay. Alright, I might know what's going on. Firstly, this flipping was definitely wrong. 2, 3, 4. Plus 2 minus 2, 3, 4. 2. Where's our update? Quad. No. That looks right. Ugh. Oh. Maybe that doesn't look right. Maybe this is my problem. This. All this quad index and this quad index. We'll make this look like the other one. Index with quad. Nope. Yep. Do the same thing up here. Yep. just for consistency. Quad index. Quad index. Quad index. Oh, there are some other measurements I wanted to take as part of today. Maybe we still can. One thing I want to do is at the end of the week, not just lines of code, I want to know FPS and release size. We can compute all that later today for last week. Okay. What do you get? While I'm thinking of things. Well, can't type. Toads, poultry with chips, laced, rhino, stone, proud. Oh, dang it! Prime lunch, toads, ultra demon chips, laced, rhino, stone, proud lines, match, beady, flogs, jacks, waxed. Okay. Hey, that's a lot closer. They just suck. Now we're close. Right, animation 1. Did raise them some. Oh, okay. Not Y0. Not Y1. Okay. Plus height. That's the secret there. That should fix a lot of issues. Because our Y is not the base of the baseline of the, it's not the quad corner anymore. It's the quad corner as raised, then subtract things down. We could make this easier maybe with a bounce in and then work from X0. No, I don't like it. I don't think so. It's not quite the same thing. R is not captured. Well, we should go capture R. So we raised it up. So when we do the bounce, we're not going from here to there. BD, flogs, jacks, wax. Okay. Hey! Click. Ah, the R did not go, but that's the bug we already know about, so that's fine. Ugh. Yep, that's definitely a problem. But now when we clear, bonk, perfect. We win! Victory. Boom. Not bad. Oh, just in time. It's almost snack time. Oh, good. Good, good, good. I was starting to get worried. Do we want to solve this one without having that bug fixed? I N O prime. This would be faster if that bug was fixed, but it's not. U D no L. W X are out. S is in. JK has one letter and BY has the other letter. Boop. BY and Jax. So we can do like jokes. No, we can't. Jokes. There we go. No J. K is in. Blank. No B. Therefore it's a Y. Dusky. Alright, we got it. Okay. That's not bad. We did it. Okay, okay. Alright. Oh, good. Good. That's the last one. Time lunch. Code, Ultrawood, event based, Rhino, crowd lines, prime, crowd lines, okay. BD, oh, interesting. Logs. It cannot be. Ooh, okay. Well, it's L and C. So it's not U and it's not T. O and S are in for sure. So F and G are out. And N is out. And H is out. Still need one more letter. Jax. There it is. So maybe like locks. Except. Whoop, whoop. Perfect. Donk. Okay. It's working. Alright. Boom. We should. It's okay. Snack break, restroom break. Then we'll come back and do some things we should have done, then commit that change. Restroom and snack break. Be right back. All right. See you in a minute. Okay, we are back. Now, I'm slightly curious which action sequence is getting already running cannot update. Can I? Game scene. What action sequences do we have? Banner? Oh. Yeah, the banner probably could be fixed up later. Let's add that to the task list. That might be a gameplay. It's not necessarily a bug. Banner animation. Unique weight. Or like we already have. Yeah, banner animations just need some help here. Okay, so bookcase, letters, animated. That's working. All right. So I said we need to get the journal and say how big our executable is and what our frames per second are. So we're going to do this. Get stash should take all these changes here and put them aside. So nothing is different from what we started working with this morning. So that word count is the same and everything. We're going to let's not go to game scene. Let's just go somewhere else. Not journal. Something I didn't edit. Maybe main menu scene. Sure. Now we're going to clean and release build. I should have checked my audio when I got back. It seems to be okay. So this is going to remove all those objects from before. You know what? Let's go clean this up while we're here. Void window. Now fix that one. Void window. Basically, it's being passed in, but we don't ever use it within the context of this function. So we are asserting that we know this parameter was passed and we are ignoring it when the release build. That should fix that. We don't want to do that though. Oh well. Because we are off the stash. So, okay, everything built. So we want to run our release version. We want to go into the game and we want the frames per second up. Lunch, goods, ultra demon, chips, laced, rhinos, still, match. It looks like we're getting about 2,000 frames per second. A bit of a slowdown from where we've had it before, but we are doing more things. So, whoa, that spiked down to 500 frames per second. That's not great if it's spiking. Still pretty stable around 2,000 frames per second. So, we will record that in the journal. Get stash. There we go. Now we can go to input and suppress all of those Void window. Void window. Window. Void window. Going back to the journal. Week 2. Our frames per second was 2000. Pretty stable. Go to the shell list, out, source, builds, release. List out everything. And it is this many bytes. So, kilo, milli, it's 11 megabytes. Let me check that against what Windows is reporting. It should be about 10 megabytes, 10, 11 megabytes. Let me find it the hard way, which you can't see, but that's fine. Active projects, word sleuth. Don't want to expose you to too much Windows. Don't want to expose myself to too much Windows. Yeah, 10.7 kilobytes. So yeah. Okay. All right. So that's our size. Bytes. Frames per second. Okay. Now, compile, clean, back to debug. Oh, the other thing I wanted to check was debug flags, link flags, release flags, base flags. No int to pointer cast. Yeah. Okay. Nothing here that I need to worry about. Compile, clean, and debug. All right. Hey, Brian, how's it going? Null pointer variable, or it's a native from C++. C++ native null pointer. It's a keyword. But yeah, bom dia. Como você está? Good, good. I've just about used up all my Portuguese, so. Ooh, which holiday is it? Okay, 6:46. So you're 4 hours ahead of me. Okay. Boa noite. Oh, yeah. You know, there's one or two like that here in the United States that I don't. It catches me by surprise too. Okay, that's one I haven't heard about either. But hey, it's a good excuse to, barbecue things and no. Oh. Where did my animations go? They're gone. Did I? So holidays around here, there are 10 or 11 national holidays, and then basically everything else is ignored. Like, there might be a holiday, but nobody takes it off. Okay. How did that not work? Yeah, so that sounds more complicated. So what are you gonna do on your little vacation, your holiday? Sleep. Good answer. That sounds good to me. So what are you working on today? Hmm. Ah, that bug is gonna kill me. And of course, S is being weird. No O. D is in, M is out. No letter P. BD does have it, so we can remove everything except B and Y. Bides. Nice. Okay, so the animations are working. Okay. Furniture fabric. Very good. The word is probably upholstery. Oh, fabric. Yeah, fabrication. Okay, carpentry. I see. I understand. Do you have furniture factory? Okay. Did I update the journal properly? Journal cleanup and extra per week info added to week 2. Four oh 708. And week stats. Yep. Okay, multicolor letters, color text. Updated to support per letter animations. Bookcase now animated like chalkboard. Bookcase. Okay. Add everything. Hit commit. Bookcase animations are done. Boom. Awesome. Like a junior carpenter, half official. Next step is assembly game. Sometimes I watch a retro games mechanic explain videos. Yeah, some of those retro programmers had to be super good at their coding. They didn't have as much resources to play with, and so they were very clever. Yeah, and the pure assembly, well, here's the thing. Assembly itself is not that scary. It's actually much simpler. It's just harder to read. There's so much less syntax and stuff, but you have to keep track of more in your head. A lot of those old games are also written on a very limited instruction set. Like it's not a modern x86 64 assembly language. It would be like one of those old chips with a lot less instructions on it. But some of the games they played with, like how they draw their graphics, were just unbelievably clever. Some of them really abused their instruction set. It's fun to watch those retro programming videos. Okay. So, in the journal, we said animating the level changes, basically. So let's do what? Let's do a level start animation. Let me see. Try to do an SNES Hello World. Yeah. Get an emulator and run it. Yep. That could be educational. Oh, processor architecture. Well, that is a complicated topic. Very complicated. Most of what you need can be a very simplified model that's not accurate, but it's good enough to get your mind wrapped around the ideas. Yeah, they're different at several levels. So x86 and ARM, they have completely different architectures, ways of approaching problems. But for the most part, there are some common things that you need to know about that are very important. One, you have an ALU and maybe a FPU. FPU. This is going to be your arithmetic and logic unit. And you'll probably have a floating point unit in there as well. In the old days, you didn't have a floating point unit. Everything had to go through the arithmetic logic unit, which meant not all the operations were optimized for floating point operations. So a lot of the old algorithms, they'd say, look, we're going to use every hack in the book to make it an integer and then operate on the ALU instead of trying to use the floating point nonsense that the CPU supports, because it's just faster. But nowadays, honestly, floating point is screaming fast on modern CPU. So this, you can think, this is basically when we say a core. This is one of the components. So if your CPU has 8 cores, it's actually got several arithmetic logic units, several floating point units in there. The next thing you need is you have memory, okay? And that's your RAM. That's where your program is stored and where your program runtime is stored. So the variables you create are all put in RAM, in memory. So you need memory, random access memory. The next thing you have is, if you think about how fast a CPU is, compared to that, accessing RAM is very slow. It's a huge block of memory, you know, however many 8 gigs, 16 gigs you have on your machine, 32 gigs of memory to address. So what you want is to have a smaller amount of memory that's used to store hotspots, right? So if you're reading through an array, you want to preload the array into something closer than RAM. So that you'll have caches, you know, L1 cache, L2 cache, and L3 cache typically. L1 is going to be a very small amount of memory, but it is screaming fast. Your CPU, when you ask for memory, it's going to first look in there. It's going to say, is this memory copied into the L1 cache? If not, that's called a cache miss. Then it'll look in the L2 cache and say, hey, L2 cache, do you have the memory I need? And if that has the memory, it loads that into L1 and then off it goes. Same thing with if it fails on L2, it goes to L3. If it fails L3, it goes out to RAM and reads that memory. So a lot of your CPU optimization that is done for you is about prefetching data into your cache intelligently, so that you don't have cache misses. That's one of the reasons you want like arrays instead of linked lists. Linked list memory is all over the place, whereas an array, that memory is guaranteed to be consecutive. So your memory, your memory accesses are going to hit the cache a lot more often. Access RAM is slow. Yes, access to RAM is slow compared to the CPU. Now, even slower is access to the disk, right? Your computer's disk is going to be even slower. And again, that depends on a lot of things. But for example, if it's a magnetic platter, it's going to be even slower than like an SSD, right? Solid state hard drive. Basically, the further from the CPU you get, the slower things get. Until we're looking at network, which is even slower. If you have to get data over the network, that's one of the slowest things you have to do. So yeah, almost all of the modern architecture deals with getting data, you know, hard drive, CD, all these things. These are going to be the slowest. So this is screaming fast. Like if you look at how many gigahertz your CPU has and how many cores, like if you actually used it appropriately, that's trillions of floating point operations per second. It's ridiculous how much power you have. And then a lot of architecture has to do with how do we get data into the cache so we don't hit RAM very often, and how do we get, you know, data cache, you know, again, sort of the same thing with the disk. It'll try to preload data for your use. Now, like you said, there's a lot of difference between the x86, you know, the Intel versus ARM. They are both probably on x86 64 types of instruction sets these days. But all that means is that there's an instruction set that runs. So what's even more interesting is, while let's just take Intel x86 64, right? The manual, I actually have it downloaded somewhere. Let me see. Where would I have put that? Let me see if I can pull that up. Did I put that in compiler stuff? Compiler. No, did I put it? Oh, well, let me just look it up. Intel x86-64 instruction set. Developer manuals. Document, hopefully. This is the whole PDF. Okay. Yeah. So if you go here, you can download the entire software development manual for Intel x86-64 and learn how to write your own assembly code for Intel. ARM is going to have a different instruction set, but here's the fun part. What they're telling you that CPU is running is actually kind of a lie. It does, the CPU deep down inside does not run x86-64 assembly language. It has a hardware layer that takes x86-64 and translates that down into what's called microcode, which the CPU then runs natively. Let's see here, microcode, boom. Intermediary layer between the central processing unit and the programmer visible instruction set. Yep, so I'll go ahead and leave a link to that too. Boom. So using the Intel x86-64 assembly code is then compiled down to microcode. This FPU, there's something related to how floating point numbers are represented as bits. Yep. A lot of old CPUs didn't have special handling for floating point numbers, but modern CPUs do. Yep. Signal 2 is about this, but yep. Correct. So you are already familiar with the IEEE floating point format standards. Yep. What is that? IEEE 1588 or something? No. That is Precision Time Protocol. I don't know why 1588 popped into my mind. It's IEEE 754. You know, that's how I feel about college. A lot of the things I know I learned after college, or I'd heard about in college, and so I knew I didn't know anything about it, and I knew what words to look up. Or the other thing that happens a lot is I'll get a task, and I'll then have to go actually learn how that stuff works deep down inside. So. Mm-hmm. Yeah, so IEEE is a group of people the who set standards for how things work. And one of those is how do we deal with floating point numbers? The IEEE 754 standard is not the only way to do it. There is, for example, what's it called? BCD. There we go, binary coded decimal. And it treats floating point numbers a whole different way. So here's how BCD works, and we're very, very glad we don't deal with binary coded decimals anymore, except in very specific circumstances. But yeah, the IEEE sets of standards are very helpful, and you can read every single one. They're all public. It's like, ASCII. ASCII isn't the only thing. There was also, back in the day, EBCDIC. Let's see, where's EBCDIC? There we go. Boom. So, we could have not ended up with ASCII 7 and extended IBM ASCII and then gone down the road of Unicode with UTF-8 encodings or, whatever. We could have gone down the EBCDIC road, a different way to encode text. But people decided to go with what IEEE was suggesting, despite its flaws. I'm not going to lie, that standard is not perfect. In your numerical class, there's a lot of very specific things to know about floating point numbers. Oh no, no stupid question. That's good stuff. How did I absorb it? In college, I did not absorb it. I saw it once, and then I did the test, and then I forgot it. Then later, when I had to know it, that's when I actually looked it up and used it. When you actually use something, that's when it becomes ingrained, right? You memorize, you write the test, and then you're done. But when you actually have to use it, that's when that stuff starts sticking in your brain. So you need a project where you maybe convert IEEE to EBCDIC or all sorts of things. You can do. Then the more pieces you learn, the easier it is to tie other pieces into it. Plus, this is just what I do. I work in code every day, all day. Done it for more than 15 years. And what's sad is I feel kind of stupid. I see people like Casey Muratori and John Blow, and they know so much more than I do. I think my career sent me back. Build converters. Yep. So one of the reasons I learned the IEEE 754 format reasonably well was because way back in the day I would get bytes of data off of a UART data channel from a device, and then I had to convert it back to float myself. So I kind of had to know what those bits were doing and how they worked. And so, for example, let's see here. This guy, I haven't actually taken his course, but I should. This guy goes into levels of how things work that I don't understand. Like he starts talking about, well, that's not entirely true. I usually understand what he's saying, but it doesn't always stick because I don't use it. But I would like to take his full course. It was like IoT. This is kind of before IoT became a thing. It was basically we were building custom laboratory scientific equipment. So I had a microcontroller. What was that? It was a Zilog, something Zilog F64. And there's no operating system. It's just whatever code you write, period. Just bare metal. There's a small C compiler. And then that would read voltages off of input channels. off of an input pin, and then I would convert it and send it along to the machine on a UART channel. Yes, the Internet of Things is, I don't think, well, I don't know. I don't know enough about Internet of Things. I know what they're doing, and maybe some of it's good, but I suspect that it's got lots of problems with it too that I don't know about. It's just kind of how a lot of things evolve. They get too high level, they start getting too many abstractions, and then you start losing control. Okay. Like I said, this gets a lot more complicated even. Like, we didn't even talk about things like pipelines and branch hits, and branch misses, and branch prediction. We didn't talk about speculative execution. Like, there's a lot going on here, but for most people, this is a good level of understanding. And like I said, there are parts of it that I don't even understand, so. Okay. So in here. Well, I'm glad you're finding it educational. It's good for me to review and speak out some of the basics from time to time too, so that I remember them. If you don't use it, you lose it. So yeah, feel free to ask any questions. I may not always know the answer, but I can usually point you somewhere. And if I don't, then I'll tell you. Okay. So our next thing is I have a couple of ideas here. One is we create a flag for blocking user inputs in specific ways. For example, while the level is exploding or falling off the screen, or while it's falling onto the screen or whatever, I don't want any user input. So part of me thinks we should have a bool m_block user typing, or block guessing, and then block deducing. Those are two different things. When you win the level, no more guessing, right? But you can go back and clear your deductions and redo all your deductions and figure out where you went wrong. So I think that's why we want to break that up that way. That's right, before frame count, which we are only using for debugging purposes. We don't want to block anything by default. What, let's see, what college did you go to? So I got a bachelor's of science, so a 4-year degree in computer science. That's it. Okay. I don't remember. Did you tell me what degree you had? 4th semester in comp sci. Yep. Yeah. So I think of a college degree in computer science as like a roadmap. Here are a bunch of topics. You're not going to learn them all, but you'll at least have seen them and know what they are. Like, you recognized the floating point, exponent
Sine, exponent, and mantissa bits from our conversation. That was something that clicked. So that's good. But you'll learn a lot more doing projects. And depending on what projects, you might learn lots of different things. So for like networking, I know some basics. I know how to get, a port and set it up and tear it down and read data off of it. There are things that I'm less comfortable doing. A lot of the higher level stuff I'm not familiar with in terms of networking. But other things I want to go lower level, haven't got around to that. Okay. So user deducing. Basically don't oh wait, no. Clear and reject. Clear deductions, reject preset. Underscore block user deducing. All right, so you can't clear the deductions in this case. You can't reject characters in this case. Key press handler. It depends on which things we're doing here. Enter, delete, submit, clear. That's all guessing. Oops. So if underscore block user guessing. If we aren't blocking it, we can do all that. Oops. Oh, there we go. Mouse press. I think it's just so this makes letter clicked on the blackboard. The deduced letter, if it's been the swapping, yep. And showing deduction spaces, that can go away. Yeah, so basically all of this only happens if we are not blocking user deductions. Lower level looks more advanced, but are there more opportunities? I don't know. I mean, right now, most all the opportunities I'm seeing are like web development, which I consider very high level. The number of people that work in JavaScript that actually think about what the CPU is doing is vanishingly small. There's a lot of opportunities in AI right now. I think that's going to crash. I think the job market will be shrunk. Focus on a sub area. In your undergrad, I wouldn't worry too much about that. But it kind of depends on what you find the most interesting. For me, I always liked simulation.
Sleuth flags are in. No. The circumstances where we don't want to accept user input. Fine. Express handler. That's interesting that all the guessing stuff is keyboard shortcut while all of the deduction stuff is the mouse. Oh, that's not quite true, is it? We do have some guesses that are wired up to things. There, set double click, left click callback. Update unmarked characters in guess. So that is a mouse handled thing. If we are not blocking deductions, and we have a valid guess index. Ooh, we should insert guess index greater than or equal to 0. Just a small sanity check. And everything else should be fine there. Reject preset characters, clear deductions. Letter clicked, we've already covered. Set letter state should be fine. Oop. Dead code. Show deduction space. Okay. I think these are already hidden inside of a check for user deductions. Yep. Show and copy are both hidden already. Show message. Mark deduced letter. Swap deduced letter. Yeah, underscore block user deduced. Hold on, let me. Sam can't code. Finally, a Vim user. Vim user. Are you trying to enter the Holy Wars? Welcome to the channel, Sam. Either that's a good troll or we need to talk about a few things. Callback. Yes, Brian. A callback is basically a function that we pass to someone else to say, you can call this, and when it's the right time. So, for example, when I click a button, I want something to handle that. I want it to do something, right? So I can set that, create a function that says, here's what to do when this function happens, when this button is clicked. And then I tell the button about it. I say, hey, button, here's the callback for when you're clicked. Right? You can have like timer callbacks. So when the timer runs out, let's do something. Or network, when you're reading off of a network, maybe you have a callback to say, hey, read all this stuff. And when you're done reading the current buffers, here's the function to call. How is it written in C++? Where is their function pointers? There are function pointers. Ooh, okay. There's a few ways this can happen. Let's go to button. That's probably the easiest one to illustrate. Button.hpp. There. I said, here is a, so you include the functional library. You say, here's a function which returns void and has no inputs, and I'm going to call it click handler. So down here, I have a click handler. So that's a pointer to a function that's takes a void and returns void. And here's the pointer, right? Here's what we're calling this variable that's going to store it. So then when I say set callback in button.cpp, set callback, here it is. So I pass in a function pointer and it sets the handler to that h that I passed in. So what does that look like when we use it? Set callback. So here's the button to clear the deductions. And I made a function inside of game scene called clear deductions. And then std_bind says, give me a function pointer given this address bound to this variable, which is complicated. But another place where I might do a callback, which is different, arrow function. Yeah, so you're creating a, so I have an example of that as well. Everywhere where I set an animation, this is the equivalent of what you're talking about. This is an anonymous function, or a lambda function. I say capture from the outer scope these variables. This function, the parameter that this function is going to get is v. Then I can take the target guess label and move it to x2 because these are both captured from the outer scope. And here's the v that's being computed for each step of the animation. So this is basically my, how do I apply this animation to my scene? So two different ways to do it. Compared to JavaScript, no, yes, this is one of the major complaints about C++. It became a syntactic nightmare. But I also don't like JavaScript, so you can't win them all. What was I working on? I was looking to see if surrender or back should always be available. These two, we did fix this one. It checks if we are blocking deductions. Button. Left click, right click. I don't know. That might be about it. I think a syntactic is necessary. Well, the C++ syntax is necessary because they refuse to break backwards compatibility. That's probably the... So C++, every time they sit down to design a new standard, their first goal is to not break backwards compatibility. So to make the new features possible, they add syntax to make the new thing possible. So C++ over the years has just gotten bigger and bigger and more bloated. Oh, backwards compatibility means means that what you type today, what you typed yesterday, will still work today. So if you change what syntax means in C++, the code you did write won't work in a modern compiler. So each time you update your compiler, you got to rewrite your code. They don't want to do that, and there are good reasons for that. There are good reasons for that, but you do have to. You have to cut it off sometime. Otherwise, you get too much bloat. Yep. Lots and lots. When I first started, it was mostly the 2003 standard. And the 2003 standard was very stable, pretty unchanging. But it became apparent it was falling behind. A lot of new features needed to be built. So they made the 2011 standard, C++11, etc., etc. I forget which all years they have. 11, 13, 17. Let's see. But yeah, 2003 was the first real standard I was using. So 11, 14, 17. There's a draft of the C++20 standard. Yep. So they just keep adding to it. Win. You can no longer guess after you win. Okay, so that should get most of that. Assuming we didn't break anything. This should not make a difference. Do a full clean. Just inhaled the last bite of my stack. Okay. I have about an hour and a half to get this last set of animations done. Let's see what we can do. Oh, I made an error. Terrible error. Oops, yep, I sure did. Wait a minute. Yeah, it goes outside everything. There we go. Compile. Yeah, C++ is not my favorite in a lot of ways. There are a few things that if C had would make it perfect, but or more nearly perfect. But C++, a lot of the things they added are just too much bloat. So let's hope we didn't break anything. Okay, so those all go. Oh no! Oh, that's fine. That's fine. Boom. And of course, L did not go. That makes me sad. Copy, copy, copy. In workspace 2, we're going to say O, D, not S. O, not D, S. Not O, D, S. 2. If we assume those things, there's already a contradiction because of proud, so this deduction gets cleared. This one's fine. P is out. No more information. Ultra, demon, chip CHI has 1. Placed rhino stump ST UMP. So M would be in here. I or E, but not N. Therefore, E is in, and I is out. C is out. H is in. Huh. Schmo? Oh, wow. Holmes, there we go. I can think through my words properly. Okay, so I don't think I broke anything. Which means we're ready to start animating the new levels. Do you love or hate C and CIA? I'm not a big fan of the CIA, but I do like C. It's low level, it doesn't add a lot of things you don't need. There are a few problems with it. If they had function and operator overloading, if they had lambda functions, if they had a decent preprocessor metaprogramming type of thing, that would be wonderful. But you don't need much more than that for C to be really good. So one of the reasons I use C++ is because it gives me function overloading and operator overloading. I still do most everything in a very C-like style. But, you know, I do shove things into classes when it makes sense. Okay, let's see. So, game scene. When we start a new level, which I guess we call next level, which we should really put down here at the bottom of initialization. There we go. Next level. This is where the animations will go. So, game context, oops. Use animations. Otherwise, just do all this. Okay. So, when we use animations, we're going to do a few things. We are going to first, let's see. Let's just get an action sequence here. Scheduler, new action sequence. And we want to, first of all, disable user inputs. So let's make 3 of these for now. Sequence. Set immediate. And the function that says m_block user deducing equals true, and block user deducing equals true. Zero action index plus. At the end of all this, we're going to set those back to false. UC experience felt desperate. Yeah, so C makes a lot more sense the more you understand what the machine is trying to do underneath that. You have to know what's happening to your memory. You have to know where the memory came from and where it's going. And the more of that sort of thing you understand, the better off you'll be. Okay, so a whole bunch of this stuff. When we win or when we advance level, the previous level is going to go off screen somewhere. Oh dear. So when we start this animation, we will not be in our original locations. We will be off screen somewhere for most of it. Which maybe we should animate that instead of this one first. Let's animate exiting the level first, while I think about what I've done. Come on, here we go. Next level. Next level sound. Next level when we first initialize. Next level is the actual function. If the game is running, play the solved sound, execute next level, and play the next level sound. Okay, so what this is going to become here is two steps. It's going to say exit the current level, re-enter the current level, or enter the current level. Yep. So I was going to say, if someone really wants to learn programming, they should start with, you should learn 2 languages. You should learn C, because there's so much emphasis on understanding what the machine is doing with your code. And then Lisp. You should learn a Lisp, whether it's Lisp, Common Lisp, or Scheme. Kind of doesn't matter. But it forces you to accept an entirely different way of thinking about that you just have to do until you get it. Once you have those 2, you may never use Lisp or C ever again. but it changes the way that your brain thinks about code. Unfortunately, I'm not the only one to say that. I thought it was a great set of insights by myself, but it turns out that a lot of other very, very good programmers, and by other I mean way better than me, have the same opinion. Like if there's a Lex Friedman talk, an interview with John Carmack, I think it was, and he said the same thing. Even if you never use them, they're probably good early languages to learn. Never heard about Lisp before. Oh dear. Okay. Well, you might want to look it up. I know I don't use it anymore, but like I said, there's a phase you go through where you're like, Lisp is amazing, and then you start running into the problems of Lisp. You're like, oh, that's why we don't use it. But it does change the way you think about the code. Okay, I have to think about this more than I thought I would. Like this here. Oh, I don't want to put that in next level. Oh, I can put it in next level. It can play first thing when you start up the game. No, let's put it back where it was until I know what I'm doing. Um, where do we want to go? Let's do this. Let's just commit what we've got. Git commit sham. Added flags to block types of user inputs. Okay. What we were worried about is this right here combined with this function here. Ugh. I want to move the playing of sounds inside of this thing here. Action sequence equals this one. It's going to have one element. This is going to be 0. Set start sound. That's that. So now when we start a level, it'll play that sound even level 1. Ready to get something like an old school R. I don't know R. I think R is more like a Python. Lisp is it's a functional language and it's very simple syntax. So actually, I just used it in the journal here this morning. So here is a list, and the first thing in it is the function or the operator, and then the list of parameters. Yeah, and then all I did was say evaluate this expression before the cursor, and it just does it. So plus takes as many operations as you want. Let's see, can I xb.emax? What? Oh, I haven't specified where my .emax lives. Interesting. In this one. Emax.emax. Here we go. So this is all Lisp. double semicolon for comments. I think single semicolon will as well. But this is a list for parentheses to parentheses. The first thing is the function, and then everything after that is an argument. So this is an argument which says the keyboard combo for control 8. This is this text, right? And then here's a lambda function which interactively changes the opacity of my window, which you can't see. Let's see, is there other good examples? Set cursor according to mode. That's not interesting. Let's see if I can find an interesting piece. But yes, it's all parentheses. Everything's parentheses. All of the syntax is parentheses. Global set key. So when I type in Alt G to go to line, right? Like 135 instead of 133, I told it that's the key I want to use that function. This quote means this is a symbol that I don't want you to evaluate. So instead of giving me the function, it gives me just the name of the function. Yeah, I don't know. It has its uses, but like I said, Lisp is not. Yes, well, this is eLisp. It's a specific Lisp just for Emacs. But there's Common Lisp. There's other Lisps. Scheme is a different kind of Lisp. Trying to think if there's one in here that I actually wrote myself. Very much. Python handling. Many windows. Oh, here we go. So this is stuff I wrote. I did not copy paste off the internet. So you can see it gets pretty complicated. But this chunk here with paired repeat, global set key with paired repeat, those are all mine. Or up line, down line. I wrote those. Yeah, I don't know. This is Lisp. Ooh, that's a whoosh. That's fine. That works okay. Because of what we're going to do next. The alphabet letters, the deduction letters, and the what else? Alphabet, deduction, the books. The words don't have to be animated in, or the guesses don't. So that's good. This needs to be broken out into a different function. So instead of next level, we say finish level, I guess. Let's do that. All it has to do, so next level. Wiki scene, finish level. Let's do this. We'll copy this much. Then trim it down. Okay. So now we change this to set immediate std bind game scene finish level. I need to wait for finish level to finish before kicking off the next one. So how will I know when finish level is done? So we need to wait sequence. Oh, on the parentheses. Sequence set wait or do until, I guess. We want to wait until underscore. Well, we're going to do nothing until Boolean fill underscore blocks user guessing equals false. We can shorten that up. That. So when we set in this, that's not gonna work. Obviously. Set immediate. Yes, play with Lisp. There's plenty of good material on YouTube. I am no longer a Lisp master. Not that I was ever a master. I dabbled. But yeah, learn a scheme. So scheme, let's see here. Scheme programming language. Let's see here. Trying to find a reasonable resource to start from. Whatever. I guess this works. So this is scheme. It's a type of Lisp. The differences are several. Let's see here. Common Lisp. Here's probably the more popular, more common Lisps. Yeah, learning tab on there, first steps, tutorials. There's YouTube videos once you know what you're looking for. A couple of good sources for you. Okay, so when we blow up the level, we have to wait for the sound to not be playing. Okay, let's do this. If game context use animations, it will behave completely differently from when we aren't. Else. Okay. we're not using animations. What I want it to do, m underscore, I don't even remember what the last thing was. XYZ. So let's go to finish level. It's the solved sound. Okay. That's the one. When M solved sound is not playing. Pretty sure that's how that works. Is playing, yes. So if we're not animating, fire off the finish level, wait for the sound to finish, and then fire off the next level function. And those are fine, but we do want to use animations, which means this condition is different. Return m underscore block user whatever. Yes. So in other words, when you return control to the player, we know we're done finishing the level and we can start up the next level, which will then block user guessing again. Okay, I think that's good. However, we are going to first test. What did I do to journal? Oh, I didn't change anything substantive. Okay. Okay. So where are we at here? We just want to make sure I didn't blow things up with the animations disabled piece. So we're going to go to settings. We're going to turn off animations. We're going to play. Okay, it swooshes in. And it's specifically when we say we finished the level, so I do have to finish the deduction on this one, which we can cheat. Where's that text? We need this word. This word. Site. Okay, it played both sounds at the same time and did not wait, so that's not good. Shoot. See it again. Yep. It hates me. I could swear and set that up right. Okay. So what do we do about it? If we weren't using animations, then we say finish the level, which will start this sound playing. Then we do nothing until the sound is done playing. And then we say next level, which will kick off the next sound. This should work. This, in my brain, this makes sense. Because I always want the option to turn off animations. For those who speedrun and for when I'm debugging, I want to make sure that the no animation feature is working. These look very similar. Finish level, next level. It starts the sound, right? Set the volume. Set play sound. Set start sound. So we block user input, we start a sound, and then we unblock. So maybe we need to hear do a wait until set, do until, wow, do until, there we go, sheesh. Plus we do nothing until this, which returns a Boolean. This statement will become more complicated as we add more elements, but it should be fine. Solved sound dot is play is no longer true. Oh, is that the problem? Do I have the logic backwards? I might have the logic backwards. Nope. If it's not playing immediate, action sequence set immediate. Oh yeah. Set immediate. If it's immediate, it updates the one time and then it will always be done. So yeah, it runs update once. And that update will do the start, which is play sound or start sound. They're playing at the same time. Make this slightly more efficient. Since it's always going to call these functions in this way, the only thing that matters is how we wait for them to be done. And I deleted the wrong line, so put some of this back in. There we go. There it is. First things first, finish the level. Then set up the next level. In this case, it should wait until that sound is done playing. Ooh. This was not captured. Fair enough. Same here. This. There we go. Maybe I didn't do a proper rebuild. Return. I should return something there. That would help quite a lot. Run it. Settings, animations off. Play. We are going to cheat like mad. The selected word was this one. Words. Go to this line. Word. That's just sad. Huh. I wonder why. I really want the no animation option to work. Finish the level. Start sound. Sound.play. It's not playing. Set it to running. Is playing. Oh, curious. It is true. So that's going to fire up to play the sound without blocking anything. Need to complicate this. So why are we not breaking? Hey, Brian, welcome back. And I am confused, very confused. I'd like to know why I'm confused. Do I just want to move on the name of momentum, or do I want to fix this? I mean, I want to fix it. Let's just move on for the sake of momentum for now. We'll come back and do a bug day one of these days. Journal. We'll throw in a bug. Level transition when animations are off isn't working. Not waiting for sound to play before finish before advancing. Okay, got a bug. We'll do a bug day one of these days. Which means our next task is this. And so we're going to block the user while it's playing this sound. We will block the user. We will play a sound. And then we will immediately unblock the user. Let's see if that works. We should put this new action that needs a parentheses. Okay, so let's see how that behaves. Play, we're going to cheat. And it crashes. Okay. Perfect. Multicolored text. Character index was less than the text length. Huh. What are we trying to do in multicolored text on line 318? We're trying to set the color at a particular character index. Where do we set color at? Change color on first bounce. Yes. But the word is empty because we didn't drop it on the shelf. Okay, so I think I know what's going on. All right, if word library is selected word, set color at. We have length. Okay. Less than target guess label point to length. That should fix that one. Oh, one thing at a time. Okay, to cheat. Word 1167. Fumes. And the letter 5 pops up. Because that's fine. Nope, that's fine. That is absolutely fine. Actually, is that fine? That is very close to not being fine. Guess submitted. If the word is the selected word, then why would we submit the guess? We just win or lose and advance. Try again. Number 5 should not have popped up there. Alright. Now, play, cheat like mad. Test, This is for testing purposes. Dregs. That sounds like those overlapped as well. Oh, Nash. Yep, that chime is still going at the same time the whoosh starts. Is that true? $3.73. Yeah, the books pop up immediately without the chime having finished. Okay, so both modes are having the problem. That's curious. Very curious. Finish level. Create a sequence. Immediately we block the user. We play the sound. Play sound should go until that sound finishes. Have I broken play sound? It is possible. Start sound. We say when we start play, do nothing until the sound is done playing. Oh dear. This used to work. I used to be able to play sounds. Sound. Why? So this causing me issues. So here's what we're gonna do. We'll go to next level. I'm going to knock that out. We're not going to play a sound on next level. Then in sound, and an action, log note. This is going to log an awful lot, although we can limit it. Playing. Sound is playing. Yes, otherwise, no. And then return. So what I should see is a few rounds of We might as well log this as well. Log note. Oop. Sound or started? Sound started, sure. Sound playing. Let's go ahead and add an offset for that. Okay. Problem number one, we do not want thousands of logged messages, so we're going to turn on VSync, so only get 60 frames per second in our log. Play, and then we cheat like mad. We find the words. Blank. Then we see what's in the shell. Sound is playing, lots and lots. Yeah, it's like a 3-second sound, and then no, it's not. Okay. New word. Fiats. The book should not appear until that sound is done playing. There's the end of the sound. The books appeared first. Well, shoot. Oh, let me think about this. This is unfortunate. This should not be so hard. I thought I had all the kinks worked out because all the other animations are working so well. Next level. So finish level. We say, give me a sequence. We immediately block the user. And then we play the sound. Log note. Blocking. Unblocking. So if I see blocking, then the sound, then unblocking, after that last one where it says no, that would be good. If I see those things going while the sound is still playing, I'm going to be mildly perturbed. Yeah. Quit. All right, settings, VSync on, play, cheat, south. So what we're interested in is what happens on the console when we hit this button. Oh. I immediately selected a new word. Blocking started the sound. It says it played the sound and then unblocked. Okay. So why did it put the books back up? I believe this action sequence is behaving as expected. but I don't believe this sequence is behaving as expected. Sequence set on start for action index. Function which log note finish level. Oh. When the user is not being blocked anymore. Action level. So what's happening to these do untils? Do nothing until this case. Play cheat. Oh, I did not turn on. Okay. Well, either way, finish level immediately fires next level without waiting, which is not what I said. Zero fires off finish level, and it increments to 1 if we are using animations. Index 1 does nothing until we are unblocked. Then we immediately start the next level, but that's not what happens. We started the finish level here. This happened. Then this fired, at which point it selects a new word. Then this function blocks. Well, the sequence we built up in this function starts blocking. You know, maybe we're trying to be too clever. Maybe we just need to make a subsequence. All right, I'm not ready for a restroom break. I drink too much water while I think about it. So, just a moment. We are back. Oops. New plan, and it's probably more correct anyways. I still want to know why that is doing what it's doing. Okay, gotta open some new gum. Usually I drink my mate with junk food, but I'm on a bit of a diet here, trying to lose some weight that I got while working a desk job due to stress and working, 60, 80, 100-hour work weeks. So I've got to chew gum instead of eat my candies. Which makes me sad. I don't actually like chewing gum. So this do until, I think it's lying to me. That sound is definitely playing. And it reports as playing. So it's the do until that's lying to me? Is that how I'm reading this? I would like this to just work. I think I could write this section better. But block user guessing. What about this? What if we just manually enter the numbers? Maybe I'm having an index issue. Maybe something's getting overwritten that shouldn't be. Although I would think that starting at 0 and incrementing should be simple enough. All right, we run it. We vsync. We play. We cheat. Lands, and we want to see what happens on the console. Well, finish the level. It's waiting for unblock one time. The blocking didn't even start. Interesting. That's not why it's not waiting for unblock. So it's running this immediate finish level. Finish level creates an action sequence. Finish level. Finish level should do the set up the blocking. Okay. Update. Sets them both to blocking. Why, oh why? Okay, how about this then? Instead of immediate, we make it last for 1 frame. And then it will do the do until. It's still open, so I can't overwrite. Executable. All right, setting the snore vsync back play. Cheat. Ready for. Checked. And what happened here? We finished level, and it's waiting for unblock, and then it fires off next level. Okay, let's change my logging a little bit then. Finish level. Modulus the underscore frame count. This. I need to capture this. Okay. Vsync on play. Yeah, FPS is 60. Now we cheat. Third. finished level fires off at 1464. At 1465, we are waiting for unblock. How did block not happen? And next level fires off. That is not blocked. How on earth? Because it hadn't been started yet, but it is now appended after next level. So next level happens first. Okay, well, I know how to fix this, I think. I was just hoping what I thought would happen was going to be what was happening, but obviously that's not what's happening. Okay. Let's go clean up our logging, because I'm pretty sure I know what's happening now. That is all behaving as expected. We will leave those in for now. This thing, I don't think we had any weird print statements. Just here. Okay. 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 Instead, what we will do, so I'm having is this action sequence is calling finish level, which is spawning a new action sequence. But upon immediate, this action sequence created here is still in the queue waiting to be started. So immediate happens, it goes to do until, and it says, hey, we're not being blocked. Move on to the next thing. So within the same frame, it comes to here and executes this stuff, which kicks off another action sequence. However, this finally starts. What we're going to do instead, we're going to change the way finish level and next level work. Is that true? Let me look at if we're not animating, this essentially does nothing. There is no action sequence. So what we're going to do, we're going to change the way those work. We're going to take an action sequence. As an input. As a parameter. Which means next level here means we need a new action sequence of length 1. Next level here is where we change things. Here we have a sequence. They also need an index, don't they? Yes, they do. Action index. Int action index. Finish level. Here. Okay. So we have a sequence of 3 things. We are going to call finish level given the sequence that we've created at index 0. We will call next level at this one, set do until something like this. And in fact, I suspect we really want to block user stuff anyways in both cases. No, let's put that back. Okay. So now, finish level gets a sequence and an action sequence. Sequence new set play new set play new subsequence at the action index it'll be one element subsequence set start sound 0. Now we can do this like this. We can do say set play sound. I don't think we want to right now. I'm gonna do it this way. So that's now the animation free version. This one is the sequence point to set play new subsequence of 3 elements. This sequence will be subsequence, 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 subsequence. set play sound. I'll just go with set play sound for now. Which means we don't actually need this, which is fine for now. Finish level should completely finish, and the next level will start. Let's just see how that looks. Of course. Of course. New action sequence, index 0. I've used parameter sequence. What? Oh yeah, next level probably isn't using it. That should be fine. Action index 3. Okay, now we see if it's any better. Settings, VSync on, play, cheat. Bucket. Well, heck. I still selected a new word for blocking and unblocking. Play sound should block. Subsequence set on start. Action index. Note. Finish level. Begin. On end. Finish level. End. So, on the first step, before anything else, you should log this thing, and then block the variables. And it should play the sound, which should wait until the sound is done. And then it will set unblocked, and then log finished level end. Oh, I know what's going on. Because this is not doing animation things. Okay. Subsequence equals sequence 0.2 set play new subsequence given the action index, and it needs 1, 2. Let's just start by giving it 3 actions. Subsequence, subsequence, or where we block and unblock. So what we just grab this for the blocking. And level begin, next level end. And we want to, okay, that's going to cause us a problem. Plus, delete. Action index. Okay. More about the unanimated here in a bit. I'm going to start the sound, and then we're going to cheat and just say set immediate, and the immediate will just be all the bookkeeping we don't want to fiddle with just yet. So all of this. We're going to change all that in a minute. But here we go. All right, see what happens. Oops. Oh, this. I suspect that this one will also need this. Okay, okay. One thing at a time. Settings, VSync on. Play, and it dies. Because the action count is not big enough. Okay, so that's where we go next. Level. Here. That is the only possible place it could be. Full clean, I guess. Ugh. Okay. So we're waiting. It's supposed to be easy. I have noticed I've got all the tools I need. I'm not writing new code in the action sequencer scheduler. But the concepts are not flowing very well. Huh. Action sequence 1 and 205. Set start sound. Oh, okay. Maybe it's not what I thought it was then. Set start sound. That's because of sequence, not subsequence. There we go. So 0, 1, 2, and on 3 we unblock. Oh, dang it, did a clean build, unfortunate. Once we get this flow to happen in the right order, the rest of this is going to come in pretty quickly, I think. So I have two ideas. One is, while it's going chime, ding-ling-ling-ling, everything floats up off the screen, and then when we get the whoosh, it all sinks back on. The other idea I have is for exiting the level, everything explodes outwards away from the center. And then it falls in from the top. And those are fairly simple animations if we get this sequence set up right. Play. Okay, so that's good. Now cheat words. Cloth. Fuck. Okay. So we finish level begin, we block, we unblock, we finish, then the next level begins, and then we select a word, and then the next level starts. So, in theory, this should work the way I intended. Marls. Now it should go ding-ling-ling, books appear, and then the whoosh starts at the same time. Not marls. New books and the whoosh. Perfect. Okay. So that is working the way we want. Okay. Number 1. We need to compute the positions of all of the widgets on the screen when we start a new level, because when we start this animation, everything will be off the screen. We want to put it back on the screen in the right place, so we won't have its original position as a reference. That original position will already be gone. But let's go to the finished level first. Let's do finished level, finished level. Let's start sound. Start sound. We're going to wait for sound. Set do until. There we go. Do nothing until solved sound is not playing. Okay, so that's 1, 2, 3, 4 actions. I need a 5th action to be this. New, oh. Set start animation, set play animation. Okay. There we go. Play animation. Set play animation. Go to count on this animation. Dot set duration. The we can use the sound length, which we called solved sound dot. Do we have a length for that? Duration. That's what I want. Duration. Set. Easy method. Easy method. I think we want to accelerate out. So quad in. Is that right? Is that what I want? Look at a easing curve here. I want ease in quart in. Quad in. Quad in is probably fine for now. Animation dot set range. Okay, here's the tricky part. We're gonna animate all kinds of things into some very strange positions. We should probably do the drift up off the screen first. It's going to be a very complicated animation. We need to move all the guesses up off the screen. We need to move all of the deduction letters up off the screen. We need to move all of the alphabet letters off the screen. And the journals, I guess. We want it all to happen. Yeah, let's just do a drift. A nice floating up. We kind of don't care what it looks like just yet. What we want is that. So, game scene. Yes, texts. We want those. Oh no. Yeah. We want the guesses. We want the deduced level layer letters. We can move all of those. We want the alphabet. Where's my alphabet? These ones. What else? Everything else is. Oh, the books. The books. Need that. Yeah, the playmat doesn't need to change, but all the books do. Right now, text quads are not doing well with arrays, so we just manually made them. That's a to-do item to make those texture quads more useful. Action sequence, GB. Okay. All right. 4 int index equals 0, index less than 4 plus index. We're going to do things with this and with this. And then what's going on here? There we go. For int index equals 0, index less than 5, plus index. Then we will do interesting things with this. Same thing with this, except we're doing 20 of them. And this one, the letters. And everything else. Yeah. We'll do something interesting with those. This double sub value. All right. So can I do all of this in one lambda function? Do I want to capture everything all in one lambda function? You know what? I think we can we? Move to move by. Let's see here. Do I have that? Move by. So we're going to go from 0 to goodness. Animation. Okay, maybe we add a feature to animation. Set range. We're just going to do it with this one. Set delta range. We're going from V to V1. We're applying a value, but we're doing something completely different with it. Set range. La, copy everything because it's just about what we want. From to the value thing. Delta value thing. That tells me what I need to know. And here's how you apply it. So up here in update. The change in value. So the last thing you need is double m_underscore last value or last let's see here. Actually, we don't need that because we already do x0 to x1. which means I have variables that I can play with that I'm not using anywhere else. I literally use y sum of 0 as my delta, which means when we start, let's not do that. Let's just go double last value, previous value. Now when we start, previous value equals 0 equals x 0. There we go. Now an update. Apply the value of our new value minus underscore last or previous value. Oop, come back. So the previous value is going up. Should play a little bigger. Okay. Then m underscore previous value. Let's see here. Double next value equals, let's interpolate. Next value minus previous value is the delta. Now the previous value equals the next value. And we are done. Set delta range from 0 to renderer frame height. So this is just going to slide up together. In theory, delta value move by delta value 0. Oh, we're doing it wrong. That's okay. We'll be consistent for now. We'll just fix it later. We don't want it to move on the x-axis. We want it to move on the y-axis. Search for move by swap all of those parameters around. Let's just, yeah, we probably cleaned, but we added values to things. So everything is going to go whoop and slide it clean up off the screen. If that's the case, reversing it won't be too bad, because we can just move it all back down the screen by the same amount. Oh. Process initialization of double length value. Oh, for Pete's sake. Ugh. Go. Some things about C that don't make much sense to me. Some of the syntax is not good. Okay. Literally just going to move everything one screen height up. Okay. That one. Pointer type, of course. Oh, well, whatever. Oh, good, it failed. Oh, cool. Go. And it needs to be returned. There we go. Now it should work. Okay. Let's get some words in. Table prime. Toads. Ultra demon. Chips. Lace. Stump. Ooh, interesting. Crowd lines. Match. We know X goes away. We know Rhino goes away. Lines are in. P and M are out. D is in. H is out. Oh, for Pete's sake. Bug. I hate that bug. U and C are out. Which means A is in. Leads. Oh, leads. Deals. Nothing happened. It did not all swoosh up like I'd hoped. Why not? That was on finished level. If we're using animations, we get a subsequence. On start, let's look at the outputs here. Finished level begins. We start with blocking. We did that like everything else. We play an animation. Start sound. Oh. We overrode it with place sound, with wait for sound. Unblocking. Oh, wow, I cannot hit the letter for some reason. There we go. Okay. It's words. Okay, proud. H-I-N. This bug is going to kill me. We may have to address that tomorrow. A-E-R-N. T is out. S is in. M is out. E-D. Logs. X. No B, no Y. No F, no G. No J, no K. Interesting. Waxed. W or X. Waves. Boom. Okay. That was incredibly slow. So let's take this duration divided by 2. So it was a little quicker. Delta value equals minus delta value. I want it to move up. Thank you. We don't have to, but we are going to. Go in half the time. Toads, ultra, human, chips, laced, rhinos, round lines, match. Oh my, this is interesting. All of those letters go away. EAD has 2, so L is out and C is out. You know what? Let's come over here and A, E, not D, A, not E, D, not A, E, D. Looking for inconsistencies. Okay, I and S are out. M and O are out because of demon. Toads means T is in, which means U. And P are out. R is in. H is in. As far as we can tell, this is a valid possible guess. Oh. Oh, goodness. Oops. TH. Hater. What hater? Could be a hater. Boop. Everything goes up. Poof. Okay. Now, a couple of small changes. Finished level. Where do we clear out current guess? Probably on entering the next level, huh? We can put that in my immediate here. This works as good as any. That will look a little better, but that worked okay. Now, up here, we enter the next level. Begin, we select a word, next level, end. Okay. We can just fall everything with a bounce. We do a lot of that. Doesn't seem too bad. Start sound. Let's some logging in here. That was very helpful. Locking. Unblocking. Starting sound. Set immediate. Resetting level, which is basically all of this junk. So we're at 0, 1, 2, 3, unblock. So that's 4 steps. So the 5th step the animation. Okay, and this will be exactly like this one, except backwards. So instead of negating the delta value, we do that. However, only if something, let's see, I'm not sure, level label x dot y. Is it greater than 0? Well, we should do this right. Less than renderer um, frame height. So we only animate the movement if we're off the screen. We'll see how that looks. I want to do something much fancier, but this might be good enough to get us started for the day. We're running a little long. All right. Play. There it all goes. Dang it. Oh. It's not in this range. There we go. That will make a lot more sense. Okay, nothing happens there. Actually, you know what? It would be really nice if this stuff fell down on... Do we do that? We just subtract our frame height from those things. So it's letters and inductions. Those are the only ones that matter. You know what? Either way, we're doing something. So let's just get that part done. If the level label is off screen, we do that. Otherwise, so it's the letters and deduction letters. And this. These can come out. We only care about this. We don't care about these. Those are invisible anyways. Letters. Level label. Total guesses. Time label. Sure. So we will hard move everything if it's the first time. So double delta value equals negative renderer frame height. Move by delta value. So they're all going to go up. This one's going to go up. And this will be an immediate thing. And then the animation will be queued up to move them back down. Because we are not negating the delta value, we will be going positive. Okay, try that out. Okay, maybe we bounce. Also, our duration is wrong. Solved, but the what's the other sound? We play the sound. What do we get? It's the next level sound. We'll do a bounce out. We'll try that. In finish level, I did wait for sound because the animation is going to finish first. Same thing will happen here. Wait for sound M underscore. Next level sound is playing. I think we need one more. Yeah, there we go. To wait. All right, let's see if this works. If this works, we may call it here. Tomorrow may be bug day. That one bug is bothering me. Play. Donk, donk, donk. Oh, that's not bad. All right, now we got to beat one so we can see the effect. Avalanche toads. Ultra demon chips. Placed rhino. Slope. Cloud lines. X goes away. RHIMO goes away. We have some good possibilities here to play with. LES, PME, those are both good ones to work off of. So let's do that. Copy, copy, copy. I'm going to state 2. Let's do PME, because Demon has ME in it as well. So let's go P, M, not E, P, not ME, not PME. Okay. Looking for contradictions. The letter D would be out here. And STU. C would be out. There's a contradiction though. So this can't be it. It cannot be MP. All right. C and S are out because of chips. U and D would be out because of proud. A, T are in because of match. And L is in there. So 2, 2, 3, 1, 2, 2, 1, 3, 1, 0, 1, 2. Okay, let's try pedal. Oh. Palette. Doesn't know that word. Let's cheat, because cheating is good. We just need to get this tested. Oh, left. That makes sense. EAPT. Left. Oof. And nothing came back down. Very cute. Okay, so next level. So we boosted everything up. Now let's check the console output. So next level begin. It blocked. Started the sound. Resetting the level. Selected a word. Waited for the sound to finish. Unblocked. That's the end of the first time we loaded the level. And that worked good. Everything came down. Then we finished the level. It blocked. It started the sound. Waited for the sound. Oh, where's the animation? The next level started, etc., etc. So, because the finished level, what is going on here? Let's just start again. Bonk. Okay. Let me cheat. Okay, so all of this just magically disappeared. I hate that. Okay, problem one. Problem one. All the bookcase stuff flew straight up. When the finished level happened, so what happened to the letters? These should have moved up as well. Why did they go away? Uh, Finish level. So why did it not say play animation in finished level? It should not get to wait for sound unless it's playing that animation. It's played that animation. Set on start, set play animation. One, two, three, 0, 1, 2, 3, 4. So that is 5 steps. And for some reason, letter text move by, they just disappear along with the deduced letters. The guesses all were fine. These went away. Where are my letters disappearing to? When I start the next level, it's them. M_level. greater than 1. On level 2, we would expect things to have moved up all by themselves. Otherwise, we manually move things up ourselves. Then we animate them dropping back down. Come on. Okay. No toads. No M, no C, no H. I and P are both in. R and N are out. E is in. L is out. U is in. BD. Logs. Wow. No B, no Y, no F, no G. Jacks. Wax. Huh. Equip. Ah, see, where did these all go? Whoa! Those guesses did not come back down. Level encrypted. Inside here. Okay, so it starts at 0, that's fine. So that explains some of my confusion. Yeah. That works fine. Private codes, introducing chips. Placed rhinos. Outline smash. No stump. No demon. R has to be in because of proud. L and A have to be in because of ultra. No C, no H because of lunch. I has to be in. E flogs. There it is. Oh, let's see here. What am I doing? There's no B, there's no Y, J, okay, Q, W, X. Rail? Really? Okay, okay. Braille. Hey, that was better. Prime launch codes. Ultra demon chips. Laced rhino stump. Lines match. Boom. No R, no H, no I, no N, no O. P, M, E are all in. Therefore, L, A, C, D are out because of laced. S is in. No T. U is in. Fumes of smoke. Oh, what? Spume. Whoop. Okay, animations are working. They're not pretty, but they work. I think we're gonna have to call it there. It's getting late. But it is working. Let's clean up some of these log messages real quick. Um, quick test drive, then we'll update our documentation and commit. Working. I launch toads. Chips. Laced. Stump. Proud. Match. Prime. Let's see here. A D is entirely possible. So we're gonna start deducing based on demon, I think. So D O not N, D not O N, not D O N. And looking for contradictions. Proud is already a contradiction, therefore that one's out. This one, U would be out because of proud, H would be out because of rhino, LC would be out, leaves S to go in, A would be in, nope, in, T would be out, and BD would not have a new letter in it. Therefore, logs. Oh dear. Not F, not G, not J, not K. Waxed. There it is. Once. Whoosh. Perfect. Okay, so that's all working. All right. Doom. Yeah, we did that one. Done. Double transitions now. Rise off screen or fall and fall onto screen. This is likely not the final animation here, but it's an okay start. Okay. One last test. We want animations off. Play. Okay. That goes away. Those go in. Those are gone. Oh, no, undo. Clear everything. That goes away. These are in. Those are out. Out, out, in, out. BD, flogs, jacks. None of that helps. Waxed. Oh. BD, cowed. Okay, so that one is still busted, and that it did both sounds at the same time. But it means one other thing. With animations. Or animations. Oh. With animations. Okay. Bug. Double change without animations plays both sounds at once. Okay, I think tomorrow might be a bug day. I think we could tackle all 4 of those without any trouble and still have time to move on. But I think we are done with animation in and of itself this week. Finally. So, tomorrow, probably be bug day. Bug day. All right, let's wrap it up. What did I change in animation? Oh, animation, I added the delta. It dash M. Added animations. Advancing the level. Boom, done. All right. Thanks for joining. Appreciate all the chat and for watching. If you want, you can always give me a follow to know when I'm streaming, or you can join the Discord. Let me get the Discord link in here. I've not done that today. All right. Feel free to join up, ask any questions. Happy to walk you through my code or talk programming in general, or really anything else, you know, literature, movies, popular culture, religion, or politics, or whatever, you know, all the taboo subjects. Yeah, so thanks for dropping by, and I'll catch you tomorrow. Bye.